So before we get started with 6.4 rhombuses, rectangles, and squares, which we're going to be dealing with 6.5 on Monday, which will be proving that we have rhombuses, rectangle, or a square, or using their qualities to decide what kind of quadrilateral it is. Make sure that you have turned in your homework from yesterday, so your page 363 and page 372. There was only one even for that, and the answer is x equals 6 and y equals 8. That was in today's comments as well. If you have any questions from that, there will be an optional meet from 10:30 to 11, but you are also welcome to comment any number that you had trouble with, and I would be happy to make a video explaining that question, and I will post it on Google Classroom. So to get started for today, we are looking at still parallelograms, but more specific types. So if we look at the definition of rhombus, rectangle, and square, also if you don't have these notes that we're looking at right now, there is a copy of it attached to the same place that you found the video, or where the video is on Google Classroom. You can either print those or you can draw each one, but you might have to pause a little bit so that you can write the things that are already printed for everyone else. Okay, so for each of these, we're talking about a parallelogram that is more specific. So a rhombus is just a parallelogram that has 4 congruent sides. A rectangle is just a parallelogram that has 4 right angles. And a square is a parallelogram that has both. It has 4 congruent sides and 4 right angles. So because each one of these is a parallelogram, not only do they have these new qualities, and we're going to talk about things with their diagonals that end up happening as well, but because they're each parallelograms, they have those 5 properties that we talked about. 5. It wasn't showing up. You looked at 4. It's 5. The 5 properties that we talked about with parallelograms will still be true. So each one of these have opposite sides that are parallel. They have 2 pairs of opposite sides that are congruent. They have opposite angles congruent to each other. They have consecutive angles or supplementary, especially we can see that with the rectangle and square because they're all 90 degrees. So any 2 of them should be supplementary. But even for the rhombus, those are supplementary. And then their diagonals will bisect each other. So all 5 attributes that we talked about with the parallelogram, true for all these guys because they are parallelograms. We're just going more specific in saying that this is going to be true as well. It's kind of like with an isosceles triangle. It has the same attributes as just a regular triangle. It still has the sum of the interior angles is 180, but then we also know that we have 2 sides congruent. If we go even further and look at the equilateral triangle, it's even more specific type of triangle. So it's kind of like that, where we're getting more and more specific in our parallelograms. So along with these attributes, because having 4 congruent sides or 4 congruent angles makes our parallelogram look a certain way, makes it conform to a certain standard when we have to make all of those right angles, we end up having certain things happen with the diagonals as well. And I think this is the hardest part to remember, because really these things, at least with rectangle and square, we probably knew in middle school, maybe not the rhombus, but the diagonals we have probably not talked about before. So it so happens that if you are looking at a rhombus, so a parallelogram becomes a rhombus if its diagonals are perpendicular, so they will cross at a 90-degree angle, and if each diagonal bisects a pair of opposite angles. So it's saying that this diagonal bisects the angle that it crosses right here, so it bisects this angle. On the other side, it is going to bisect the other angle. Remember that already with a parallelogram, that these angles, the alternate interior, would be congruent, so that means that all 4 of those will end up being congruent. Same for the other diagonal, it will just have a different angle measure, but it will be bisected on both sides, and then they will end up being the same as well because of alternate interior. So you'll end up with these 4 all being the same and those 4 all being the same. Notice this is if and only if. So if we're dealing with a rhombus, then this has to be true, and if this is true, then we have to be dealing with a rhombus. For the rectangle, it only has one special attribute for its diagonals, and that is that its diagonals are congruent. If we think about like a letter, this kind of looks like a letter, and just looking at it, we know that the diagonals are bisected because it is a parallelogram, but not only that, they will all end up being the same segments because their full diagonals are congruent as well. And then squares, we don't have to write anything specific for them because they're going to have all of the characteristics of rhombuses and rectangles, as well as parallelograms, because they're also a parallelogram. So the square really has it all. It is going to have opposite sides parallel, opposite sides congruent, all four angles congruent, angles supplementary to each other, consecutive angles supplementary to each other. Diagonals will be bisecting each other, they'll be congruent, they will bisect opposite angles, and they'll be perpendicular to each other. Which, by the way, on Monday we will start to look at, we're going to do a couple of different ways to put all of these properties into like a chart. We'll look at a flow chart type of thing, and then we'll look at like a check mark type chart. But we'll work on some different ways to remember the attributes. Typically students don't have as much trouble with these, but remembering those diagonals. If you want to go ahead and make like some flashcards or something, that might be helpful. So we end up with a family tree of sorts where we have, if this is the parallelogram family tree, so the parallelogram family, if you've got the rhombus, that wasn't too pretty, was it? The rhombus and the rectangle are the parents of this family. They're both parallelograms, so that's their last name. You got rhombus parallelogram and rectangle parallelogram. You decide which one is the wife and which one is the husband in this situation. I don't know. But then their more specific child that has both of their attributes would be the square. So the square is the perfect child that has the attributes of the rhombus and the attributes of the square, and the attributes of the rectangle. Even further than that, it will have the attributes of the diagonals. For the rhombus being perpendicular to each other, it will have the diagonals bisecting opposite angles, and then from the rectangle, it will have the diagonals congruent to each other. So that is the perfect square. Okay, so now we're just going to look at, on the back of your notes, going through some examples of using the fact that our parallelogram is a specific type of parallelogram to solve for missing angles or sides. So the first example, we're looking at a rhombus, and we might have to look at the attributes for today, that's okay, but we're learning them as we practice. And one of the biggest angle finders for the rhombus is that these diagonals cross at a 90-degree angle, and that's going to unravel some things for us. So I know that because it's a rhombus, that Z has to be 90 degrees. We could go ahead and mark our 90-degree angle there because these diagonals are perpendicular to each other. I also know that my opposite angles get bisected by the diagonal. So I know that these angles are all the same. And I know that these end up being all the same. I'm not going to mark those because it's going to make this rough looking in a hurry. But that means that this angle will be 30, this one will be 30, and also W will be 30. And just because we have new rules doesn't mean that we throw out old ones. So at some point I will get stuck because I don't know any of these four angles that are all congruent. What I do know is that I have two of the angles out of the three in this triangle. So I can take my 30 plus 90 plus X, and that should equal 180 in this triangle. So my 180 minus 120, get that X is 60. And then, because we talked about these four angles are all congruent to each other, that means Y has to be 60 as well. I ran out of room. So mainly here using that the diagonals are perpendicular to each other, so you've got to have right angles in the middle, and then the diagonals bisect opposite angles. So we end up with 4 congruent angles here, 4 congruent angles here, all because it was a rhombus. Example 2, we're looking for missing variables of a rectangle. And then they also tell us lengths of, let's see, we've got AC and BD, so they tell us the full diagonals. But let's solve for angles first. If we're finding this angle Y, my diagonal does not bisect opposite angles, but what I do know about the rectangle is that this angle is 90 degrees. In fact, they're all 90 degrees. A giant one there. So that means that Y plus 20 has to equal 90, or Y is 70. For solving for Z, instead of straight going for Z, I'm going to look at the information that I have, my AC and BD, and I know from possibly looking at my properties on the other side for now, you'll definitely have to flip back and forth or looking at them while we're working on homework, but I know for the rectangle that my diagonals are congruent to each other, so that tells me that AC will be congruent to BD. I can subtract my 7x from both sides and add my 14. The x is 9. We're finding all variables, so that was important. X is 9, but now if we're going to use that to find Z, I can plug in my x back into AC to find all of AC. End up with an 81 minus 14. If I want to check myself for the other one, I could plug in 9 there and make sure I'm getting the same thing. So plug in 9 and get my 63 plus 4 is 67. I got the same thing here. This is 67, so that's comforting. But then, since this is a parallelogram, it still has the attribute of the diagonals being bisected. So if AC is 67, that means that the middle to C or Z will be 67 over 2, or 33.5. So this is my Z. Okay. So using the fact that I've got 90-degree angles in a rectangle, diagonals are congruent, and then because it is still a parallelogram, the diagonals are bisected. For number 3, and I would challenge you all to pause this for these last two. Pause it before I go over it and see if you can solve for the missing variables on your own first before listening to me explain them. So for example 3, I have, let's start with angles. So looking for my angle X, and it looks like I don't have a whole lot of information, but remember these are all the same. Which makes some sense, by the way, that these angles would be the same because a rhombus has 4 congruent sides. So that means that the base angles would be congruent in this triangle. It's an isosceles triangle. So I know my X is the same value over here. So in this triangle, 120 plus X equals 180. So we get that X is 30. To find Y, I'm looking at the sides, and I've only been given 2 sides, but I know that in a rhombus, all 4 sides are congruent to each other. So I do know that 2y minus 4, it doesn't matter which 2 sides they give me, I know that they're all the same. So I can set these equal to each other. And we get that y is 8. So using the fact that diagonals bisect opposite angles, using all 4 sides are congruent in a rhombus. And then with example 4, we're looking at a square this time, so really any of our properties that we've talked about so far would have to be true of the square. So I'm going to go to solve for angles first. I know that it is a square, so all of my angles are right angles, so my y is 90 degrees. Because a square has attributes of the rhombus, that means that these angles, the diagonal bisects opposite angles. And since that full angle is 90 degrees, that means that x would have to be 45. So all of these would end up being 45. Or I could use the same thing that we did on that last example, that this is an isosceles triangle and I've got 90 plus x. You could use that as well. And then to find my w using the sides, similar to the rhombus, I know that all of the sides are congruent in a square, so 4w minus 7 does have to equal 9. We get that w equals 4. So while you're working through this homework assignment, it's going to be very similar. It'll tell you what kind of goodness, that word came out weird. What kind of parallelogram you're dealing with, and then you're using whatever properties that has. So for this assignment, I would definitely keep this side of the paper up, and you're going back and forth saying, okay, I know it's a rhombus. What can I use based on that? So based on the sides all being congruent, it's also a parallelogram, but then I've got all of the diagonal attributes as well. Sorry, that's the bell. We shall pause. Same thing for a rectangle. I can use all of the parallelogram properties, but then I also have all angles congruent to each other, all right angles, and the diagonals are congruent to each other as well. So no harm in using this while you're working on today's assignment, but be trying to remember which one is which, and just by working through the assignment properly, you will start to remember them. But it is definitely a hurdle in this unit to remember all of the properties. So starting to work on those, and we will definitely work on them starting Monday in class, trying to remember what goes with what. But have a great weekend. You do have an assignment posted on Google Classroom for you to work on page 379. And remember to ask any questions in the post for today if you have any questions from yesterday's assignment. If you've done this before 10:30, you're welcome to come into the 10:30 meet and let me know any questions that you have from this or the homework for today. So have a great weekend.